Now in this next subsection focused on the introduction to machine learning, we're going to look at some actual examples, very simple examples of machine learning in using building data, and specifically the Building Data Genome Project 2, the data set that we've been looking at over previous sections when we looked at the way to visualize data and perform various types of more simplified analysis. What we'll do today is take a look at BDG2. We're going to go into the code area, and I'll post a link to the notebook that we're going to be using. The notebook itself will be called BDG2 Supervised Time Series Example. So you'll open that file and you will go ahead and make a copy into your account so that you can use the copy and follow along in this process of learning about ML applied to this data set. The first thing we want to do is just a review of what you've seen in the previous subsection. But this time I want to dive in deeper to the scikit-learn machine learning library, which we'll be using in this notebook, which you've been introduced to a little bit in the previous notebooks, and that it's like the multi-purpose machine learning library for Python that a lot of people get started with. Here you can see, you can go to the website if you want. Here's a screenshot of the beginning of that website, the top of the website. And of course, just pandas, we have a cheat sheet that we can use. And so this is the different types of models that are available in the scikit-learn library. So if you are looking at starting point of doing machine learning, first question you ask is, do you have enough data? Yes or no? Yes, if you do. Are you predicting a category or are you predicting a quantity? If you're predicting a category, you have labeled data usually. If you do have labeled data, you're doing a process called classification. If you don't have labeled data, you're doing a process called clustering. On the other hand, if you're predicting a quantity, you're doing something called regression. You're basically forecasting or creating a regression of what values will be potentially in the future based on different inputs. There's another category called dimensionality reduction, which goes a little deeper into segmentation of data, but that's okay. We don't need to look at that today. And really what we're looking at today is regression. We're looking at ways to take a model, train that model with data from a period that we might consider the historical period or the training period, and we're going to predict future data, or we're going to make a prediction in a sense. The first thing we're going to do is load the pandas library, and we can load the scikit-learn library. There are various other things that we're loading here, including scipy and datetime library. We're looking at a few different functions that we're bringing in from the scikit-learn library. And what our goal today is to look at electricity prediction using regression for measurement and verification. Instead of basically forecasting the future, what we use this type of prediction for is this scenario that we can see here, where you have the blue line, which is a baseline energy period here on the left of this middle section. And this is really what a building or a submeter, the consumption that it's using during what's called the baseline period. And we do something to the building. Maybe we change the lighting to LEDs, we upgrade the chilled water plant, various other types of energy saving optimization, retrofits, things like that. And once you make that intervention, the blue line you want to continue to calculate into this future period, which is called your adjusted baseline energy. And this is really what we're trying to predict. We're trying to use training data from the baseline period to make a baseline predicted consumption. Then what actually happens when you implement that energy saving measure is that the energy goes down. And the difference between actual energy consumption during the measured or reporting period as compared to your baseline model, your test data set, that delta is the theoretical savings that are avoided due to your intervention, whatever intervention that you've done. There's a few links here where you can take a look at a publication that focuses in this context. There is a machine learning competition called the ASHRAE Great Energy Predictor 3 competition, which we'll bring up closer to the end of this section. But in this notebook, we're going to dive into an actual example of creating a really simple machine learning model. Very similar to the subsection that you've just completed, you will be looking at the different ways to train that very simple model and see the results of that model. So we'll be stepping through the different parts of what you've learned in the previous subsection. We'll be doing things slightly differently. We won't use quite all of the functions that you learned about in the previous section. We'll use some of them, but not all of them. And then we will dive into more deeper, more detailed types of machine learning training in the upcoming sections. So, of course, the first thing we need to do is go ahead and load the data set, the electrical meter data set. Once that's loaded, we can do a .info just to get a sense of what we've got here. 2016 to 2017, 2 years of hourly data, 17,544 entries. There's 1,500 columns. If you remember, those are all buildings, meters, electrical meters, whole building electricity meters. But let's pull out one building. Let's look at an office building, Hannah, which is part of a site called the Panther site. We go ahead and load that file using a data frame. We go ahead and pull out that particular data for that particular office as a data set, and we're going to truncate a whole year of the data. So we're just going to look at that first year. We're going to look at 2016 data. We're going to use forward fill to fill in the blanks, fill in the gaps. And what we'll end up with is a single data frame with a single building. And we're only looking at 2017 data. And we have 1 year basically of data that we're going to use in this example. We can go ahead and plot that data real quick with a quick line chart. Here you can see that's hourly data, so there's quite a bit of noise in there. You can see that slowly over the sort of summertime period, the consumption seems to slightly drift up and then maybe back down a little bit. You can see some outlier behavior and things like that. Next, we will go ahead and load the weather file that is associated with the entire Building Data Genome 2 project. We will go ahead and pull out the weather data for only 2017 for the site called Panther. And if we quickly look at that weather data, we can see that we have air temperature, cloud cover, dew point, the different types of weather variables that might be interesting to help us predict electricity consumption in this building. Next thing we're going to do is we're going to resample this weather data at the hourly level, because some of the data is not, it's at different types of timestamps, not always hourly. We want to remove the really big outliers. We're going to fill NA so we have no gaps. We're going to end up with one of the data points, temperature, which we're going to use in our modeling process to help predict the electricity consumption, because as the outside air temperature maybe gets higher, the energy consumption could possibly get higher, or vice versa. If it gets very cold outside, energy consumption could get much lower. Let's go ahead and plot that temperature data here. You can see that in this particular location, you've got sort of cold winters between even 5 degrees to 30 degrees. You've got warmer summers between 20 and 35 degrees Celsius. And so this is a nice complete data set with all the gaps filled, everything nice and ready for us to do our supervised learning. In the next video, we'll dive into that train test process. We'll create our first model using this data, and we'll look at ways to capture the accuracy of that model, or how well that model does.